So let's move on. Our general strategy will be the same in all of these. We're going to try and factor the quadratic and see if we can make a cancellation with our denominator. So I'll rewrite this. We have x squared minus 9 divided by x minus 3. But notice that the quadratic in this case is a difference of squares. So you can remember that formula when you have two numbers squared and you're subtracting one from the other, that this factors into a minus b times a plus b. So in our case, we just need to figure out what is squared in x squared and 9. And you can notice that 9 is really just 3 squared. So we can factor this into essentially the first of these numbers squared, the x, minus the second of the number squared, so minus 3, and we're ignoring the squares once we factor it. And then it'll be the first one plus the second one, so x plus 3. And you can check this by redistributing, remultiply these out, and show for yourself that it does equal x squared minus 9. And we're dividing by x minus 3. But notice we have an x minus 3 in the top and an x minus 3 in the bottom. And so we can divide. X minus 3 divided by x minus 3 is just 1. So our final answer here will just be x plus 3. We're able to simplify this down to just a linear expression here. So we can put x plus 3 into the box. Now, one other way to check this is for these to be true, we can multiply each side of the equation by x minus 3, and that will cancel it out on the left. And then you just have x plus 3 times x minus 3, which you'd remultiply out and see for yourself that it does equal x squared minus 9. So there are a couple different ways that you can check these problems, but you definitely should check each problem before submitting an answer. So let's do another one. And it looks like we have another difference of squares. So I'm just going to rewrite this as x squared minus 6 squared, since 6 times 6 is 36. And we'll divide by x minus 6. And from the formula, remember it's always the first number minus the second number. And we're ignoring the squares when we factor it. And then the first one plus the second one. And this will all be divided by x minus 6. And from here, notice that the numerator and denominator each share a factor of this x minus 6. So we can divide, we can cancel these out with each other. And we're just left with an x plus 6. So that will be our final answer here. We can put x plus 6 in the box. And let's just do one more. We have another quadratic expression, which we can factor. So I'll rewrite it, x squared plus 6x plus 9 divided by x plus 3. And we'll separate this into a product of two binomials so that we can factor it. And this will all be over x plus 3. Now the first term in each of these binomials is going to multiply to x squared, because the coefficient is 1 for x squared, so we're not going to use the grouping method, which is, like I mentioned, a little bit more complicated. But since it is just a coefficient of 1, we know that this is x and this is x as well, since x times x is x squared. And then we're looking for the numbers here, which are going to multiply to our constant term. So we're looking for the pairs of numbers that multiply to 9. Could be 1 and 9, could be minus 1 and minus 9. Could be 3 and 3, or let me make just a bit more room. It could be minus 3 and minus 3. And then to determine which of these four pairs it could be, we know that it's also going to have to add to this coefficient on x. So it'll have to add to 6, which means that 3 and 3 would be the pair that we need. So we can factor this as x plus 3 times x plus 3. And we would check it by just redistributing. Multiply the x to both of these, multiply the 3 to both of these, and you'll see that you get back this quadratic expression there. So notice that we have x plus 3, or actually two of them up top, and we have one below. So we can divide. X plus 3 divided by x plus 3 is 1. So that one and that one would cancel. And 1 times anything is itself, so we end up with just x plus 3 as our final answer here, which of course we can put in the box.